You've read the rules, you've created your strategies, you've put in the time, you've done the math. Now it's time to show us what you've got. Welcome to this week's episode of FMA Plus.
Welcome back for week 9 of FMA Plus, showcasing team stories from around the region. This week, we've got Team 272, the Cyber Crusaders from Lansdale, Pennsylvania. We've got 1626, Falcon Robotics from Metuchen, New Jersey. 316, the Lunatics from Carneys Point, New Jersey. And Hall of Fame Team 341, Miss Daisy from Ambler, Pennsylvania.
Awesome. So we're here with Team 272, the Cyber Crusaders out of Lansdale, Pennsylvania. I have student representatives Megan, Joe, Aiden, Megan, and Leo, and they are accompanied by their mentor, Mrs. O'Gara. So with that, I'm going to hand it off to you guys. I'd love to learn a little bit more about the Cyber Crusaders.
So I am Megan. I am one of our team's 2 co-captains, and this year I was our strategy lead and our drive coach.
Hey, I'm Joe. I'm one of the team's other co-captains, and this year I was going to be the operator.
Hey, I'm Megan. I was the engineer lead this year, and I was also the pit manager, co-electronics lead, and the climber lead.
I'm Aiden. I was the lead for the shooting and indexing mechanisms, as well as a member of the pit crew.
Hi, I'm Leo. I'm the programming lead this year.
That's awesome. It's nice to meet you guys. Now, I'd love to hear, Megan, a little bit about the team, and also it says here about your work in the off-season, prepping for this year.
Yeah, so we are Team 272, the Cyber Crusaders. We're a high school team from Lansdale Catholic High School, and this is our 23rd season as a team. So during off-season, we had numerous local demos to showcase our 2019 robot to our community, and we also hosted our annual events such as our FLL Summer Camp, our FLL Tune-Up, and our FRC Boot Camp. Along with that, we also had our students mentor an FLL team, an FTC team, 5 FLL teams, and 3 FLL junior teams during their own seasons. And finally, we introduced all of our new students to the team and the program, and we attended 3 off-season events, Girl Power, Havoc, and Ramp Riot, so that all of our students got an opportunity to see a competition and interact with the robot.
Wow, nice. It sounds like 272 didn't get the memo that the off-season is an off-season. It sounds like you guys have been busy year-round, which is super productive and only going to help you guys in the long run, right? So, Megan, let's talk a little bit further down the line now. So, you're moving into the kickoff phase of the year. What does that process look like around kickoff?
Yeah, so our whole team meets at LC and we all watch the big reveal and for the new game announcement. This whole process is of us going through we go through a whole game we go through the whole game manual to make sure everyone knows the rules and regulations for this year. After that, we go through our priority list. For the past couple of years, our priority has been fast and maneuverable. However, for this game specifically, we wanted to score in the high goal, and we also wanted to be able to climb in the end game. This year came with many decisions based off of our priority list during our first week of build season. Well, this year there wasn't a no stop build day. We wanted to keep like a soft stop build day goal for ourselves, so that way we could give our programmers like ample amount of time with the robot before the competition. During the first week, we have our students come up with ideas and we vote on them using a weighted decision process. By the end of the week, with that, we have our robot designed on the way we want it to be. This year, we had a couple of our students start working with CAD, and it was really helpful with the design process on our very compact robot.
So it sounds like you have a good process to make decisions this season. So maybe let's walk through the robot from the ground up. Let's hear about it.
Yeah. All right. Yeah. So this year we decided to name our robot Death Star, affectionately named Dorothy, due to the unintentional oversight where we placed the battery and the switch right next to each other in the back of our robot. We really hoped this year we didn't have an opponent whose robot was named Luke Skywalker. We knew this year that we wanted to make our robot fast and maneuverable since we would be needing to go across the field in order to get power cells, and we wanted to have an increase in cycle time. For the past couple of years, we have been working with Swerve Drive. However, we realized that there may be issues crossing over the beams multiple times during the match. With this in mind, we decided to create a smaller robot to go under the color wheel would be the best solution, so that way we wouldn't have to worry about any sort of tipping or injury to our swerve drive. However, the swerve drives do come with another set of issues that they take up 8 spots in the PDP. With our robot already having multiple goals we want to accomplish with all these motors that need their own motor controllers, we debated if we wanted to bring pneumatics into our already crowded robot that we haven't even started planning out the electronics board yet. Eventually, we were able to limit some of the motor controllers down, trying to get some for multiple purposes, and created a placement for the electronics board. We solved this by using one of our unique features of having our robot have a latch that would allow the top half of our robot to open up to get to the electronics board. Affectionately, we call this car drive bank sticking to the Star Wars references on our robot.
Nice. Yeah. I love the idea of designing for accessibility, right? I think that's a huge benefit when it comes to competition season. I also like the idea of committing to a drive base style, right? You guys pick the swerve style, and then that kind of played a role in the overall height decision of the robot. That's a cool progression of decision making there, which is awesome. So Aiden, let's move on to the intake. I'd love to hear more about that.
Yeah, so this year we decided to go with an over-the-bumper style intake. After last year, we had some problems with our through-the-bumper intake, in which the frame was weaker at the front part of the robot and therefore could bend easier during matches. So we went over the bumper using a 4-bar assembly designed in CAD. We also made the intake the full length of the robots, so it would reduce the need for driver precision during the matches. So we can actually pick up two power cells side by side in the intake to bring them in, and so our drivers don't need to worry so much about lining up with the power cells, and they're just able to pick them up. With the CAD, we are working on designing more parts in CAD, and the 4-bar assembly was actually one of the parts that we had manufactured off-site using the CAD designs, which is a change from how we normally hand make our parts at our school.
That's awesome. I love the idea of designing for sort of driver ease of use, right? That's really smart. So let's keep going. You've got your power cells, you've got them in the robot. What next?
So once the power cells are brought into the robot, we have a gravity-fed trough that brings them through the length of the robot back to the shooter. So our shooter this year, still going with the theme of ease for drivers, we have a turret-style mechanism that can actually turn side to side about 16 degrees each way for the azimuth, as well as we're also able to adjust the shooter hood angle and the flywheel speeds. So we call this part Vader, which stands for the variable azimuth and dynamic elevation rapid fire. And using that paired with Limelight camera, we were able to get a targeting system up that allows the drivers to line up for shots easier.
Nice. Megan, let's talk climber. How does 272 handle the end game?
That we recognized that this was like a main part of the game, so we really wanted to have a reliable climber. So we have a scissor lift that is connected to a cable with a winch that allows us to have multiple attempts. The scissor lift will go up with the drivers while the drivers will be in control and able to using a camera we have mounted on the side facing up. Once the drivers have hooked onto the bar, the cable and the winch are the things that are actually pulling ourselves up. Once we are up, our robot is able to stay up until the end of the match using our winch that is put in place with a motor to keep it from back driving. However, we do notice that with the type of material we use as a cable, we have to climb a little bit higher up because the fact is that our robot will slowly start to lower after the power is shut off.
Oh, it's really good that you guys recognize that and then sort of plan your match flow around it. That's definitely the sign of a smart team. Now, I've loved the dive into the robot, but also, like you guys touched on earlier, you worked on elements of your process this year. So I'd love to hear sort of your reflections on what worked and what didn't in your build season.
So I'd say that working more with CAD definitely helped with our design process this year. So as for the robot parts, the intake and shooter mechanisms worked very well. We were able to pick up power cells pretty easily, and the programming team got the targeting to be very accurate. With the climber, that mechanism worked well, but with the scissor lift that we had, if the robot was tilting to the side, once the hooks were attached to the bar, it actually caused tensions within the scissor lift that would cause it to break. We didn't get that completely fixed by the time the pandemic started. And then with the color wheel, as mentioned earlier, we did have limitations on the motors because of the swerve drive, as well as deciding not to use pneumatics this year. And so we actually did not have any extra motors left over for a color wheel mechanism, but we got around this by tying a spinning component of a sort of arm to the same PDP as the intake. We had two bag motors running out of there, as well as we could actuate that arm by tying it to the azimuth rotation of the turret.
So Leo, you've been quiet. Maybe you can walk us through some of the programming processes and maybe some of the challenges the programming team saw this year on 272.
Of course. So first, our team uses Java as the main programming language. And one of the special tools I would like to talk about is our config file. The program reads the data from a text file and then uses it as a variable instead of just hard coding them into the program. It allows programmers and non-programmers to change the variables for the robot more efficiently, no matter if it's a changes in angle, speed, direction, or position. The only step to change the variable is to open the file, find the location of the data, and re-enter it with a new number. Our team uses WinSCP to store the config file, which allows one local changes transfer to every computer. We also train the new programmers with fundamental knowledge of Java by YouTube videos, online Java problem, and the AP Computer Science textbook. Then we taught them the specific robot coding by explaining the 2019 codes line by line. This process even continued during the quarantine time, and the new programmers will be ready to go next year.
Sounds like your incoming students are very well informed for their next season and for continued iteration. So Joe, one of the other things I know you guys wanted to talk about tonight is Team 272's media. So what would you like to share with us?
So on our YouTube channel, we produce weekly build season videos every single year, and this year was no different. Something new that we have to our YouTube channel this year and also on our website is we now have full videos of the seminars of our bootcamp posted. So you can see the full seminars of the engineering roundtable, of the judging seminars, of the programming seminars, CAD, whatever. And we're hoping that this is something we can continue into the years for the future. Also new to this year is we were making a reversible bumper tutorial video set. And we only got halfway through before the pandemic started and we didn't get to finish it. But we're hoping after we get back, we can upload the last 2 videos. And so for the next 2021 season, there'll be a full video set on the FRC bumpers. For our imagery, we make special competition shirts every year around the theme. And so in 2017, they were steampunk themed. In 2018, they were arcade themed. So this year they were Star Wars themed, and they were pretty cool in my opinion. We also make custom buttons, wristbands, and business cards that we hand out at both competitions and all our demos. And they're really great ways to get our names out there and get people to just be reminded of us.
You know, one of the things, Libby, maybe you can weigh in on this too. It seems like this is one of the areas that a lot of teams haven't really spoken about in FMA Plus, their media production and their attention to, you know, merchandise development and branding around the game. It's pretty cool to see you guys putting some time into that as well. Joe, real quick, can you speak a little bit about the awards effort that 272 goes into year to year?
Yeah, so we really do try really hard for the awards. For chairman specifically, we wanted to improve the process that we had with dealing it. In years prior, we had usually started our hard work on chairmans closer to the build season, but this year we decided that we really wanted to have it done early so we could give our team more time to prep and give our team more time to focus on the robot during the build season. So we made sure that prior to the build season, we had the entire script for the presentation finished, the entire essay finished. So it opened us up to work in other areas during different times. Another thing for chairmans is we have a really big graduating class this year. And so we wanted to make sure that the younger students who are coming into the program are going to be fully prepared, who are going to take up the leadership. So our entire presentation team was made up of underclass, and it was 2 sophomores and a junior. So we made sure that going into the next year, the team would be prepared to carry on the awards program.
Yeah, I definitely appreciate the dive into your awards process. And I think every team can learn from another team's process, whether you've done chairmans for years or you've never done it before. So thank you for the insight into that. So Megan, what have you guys been up to during the quarantine?
So once we realized that the 2-week period of no school was going to be a lot longer, our team decided to have weekly meetings every single Tuesday so that we could discuss the week in general and make plans for any upcoming events, and also just stay social during a time of quarantine. We also decided to hold CAD classes every Monday, Wednesday, and Thursday so that we could teach newer students CAD and also participate in OnShape's Robot to the Rescue Challenge. And we partnered with Team 433, the Firebirds, for this process. We also hosted many team meetings during the FMA Plus award show and the Forced award show to congratulate all teams who won anything.
272 has all their bases covered for sure. It seems like you guys have utilized your time well, not just in build season, but in the off season. And obviously, while we're all still sheltering in place right now due to the pandemic, you guys are remaining busy and you're remaining productive, which totally vibes with your slogan. Can anybody tell me the 272 motto? It's one of my favorites in FMA, I gotta say.
The 272 motto is "We will either find a way or make one."
That is awesome, for sure. So with that, one last question for you guys. If we want to learn more about 272, the Cyber Crusaders, where can we go to learn more?
So you can find us on our Twitter at Cyber Crusaders or our Instagram at 272 Cyber Crusaders. All of our videos are uploaded on our YouTube channel, which is Cyber Crusaders 272, and our Facebook, which is FRC 272 Cyber Crusaders, and finally our website, which is www.lcrobotics.org.
All right. And with that, thank you, Team 272 Cyber Crusaders. It was great to talk to you guys, and we'll talk to you soon. All right, so we're here with Team 1626, Falcon Robotics from Metuchen, New Jersey. Super excited to hear more about this team. And with that, I'm going to tee it off to James. James, love to meet 1626.
Thanks, Jeff and Libby, and thanks everybody at home. We're really glad to be here, and we'd like to thank you for having us on the FMA Plus podcast. So like Jeff said before, I'm James. I'm a senior at St. Joseph High School. And I'm also one of the co-captains of the team, as well as the electronics and pneumatics lead.
Hello, my name is Gregory. I'm also a senior, and I'm the other co-captain of the team, a build captain, and the driver along with Aaron.
Hi everyone, my name is Erin. I'm a junior. I'm the build captain this year, as well as the operator on this year's robot.
So the three of us make up the leadership team, or the leadership core for Falcon Robotics Team 1626 out of St. Joe's and Metuchen. This year has actually marked our 15th year as a robotics team, and we currently have about, I'd say, 60 members, including Erin from Mother Seton Regional High School. We're actually currently working with the administration at Mother Seton to recruit more girls to the team and create a kind of a joint team between the two schools. One of the interesting things that kind of sets our robotics program apart from other ones is that the robotics itself is offered as a co-curricular activity as well as a club. So you can either do robotics as a club, or you can do it as a co-curricular and actually get course credit and have it factored into your GPA at the end of the year. We're super grateful to our mentors who've actually been with the team for many years, most of whom have actually been here since we've started. And we're super grateful for them and their dedication to the program. And in fact, some of the graduates have actually come back to mentor the team, and one of them is actually there with his father. We believe that their dedication to the team matches our own, and despite the fact that we come from a small all-boys school with a small team.
What a special way to celebrate that 15th season and to, expand your team and do all this awesome work with another school. Why not celebrate, an awesome 15 years by expanding and making that legacy even stronger? So going into this year specifically, Gregory, you're supposed to tell us about our off-season events and leading up to the kickoff this season.
Yeah, before the kickoff of the season, we in order to introduce new members of the team to basically what robotics is about, we compete in off-season events in the fall. This allows us to basically teach new members what competitions will be like during the season. It also helps us train any new drivers who are thinking about driving, and basically make the team get to know each other a little bit better. And then we eventually lead into the kickoff party, where our school gathers in one building and we watch the game reveal on active wall, and we download the manual and start reading immediately. Once we have a basic understanding of the game, we determine different groups for strategizing, and especially for this year, we had 4 main parts that we wanted to focus on. So we had 4 groups: 1 for programming, 2 for build, and 1 for strategy.
Awesome. Yeah, it's cool to learn more about how teams handle the beginning of the season, right? The kickoff and the strategizing, and how you guys actually tee yourselves up to move into build season. It's interesting to see where those perspectives are formed and how that molds into your final product. So with that, I want to learn a little bit more about the actual robot that 1626 produced. So Erin, let's start at the bottom, right? Can you tell us a little bit about the drivetrain?
Working on and designing the drivetrain has always been my favorite part about build season. It was the very first thing I had done my freshman year on the team, and I've taught others and worked on it for my other 2. We've always done a tank drive, which I love doing, don't get me wrong. And we decided this would be a great year to do it and a great game to do it. The tank drive with an 80-20 frame allows for a very sturdy defense. The frame is strong, so it will not bend or snap when facing high-speed defense. And the tank drive makes it just a little bit harder for people to push us, but easier for us to push them. In the past, we have used a 6-wheel tank drive with 6-inch wheels. Because we needed to be much lower to the ground, though, we decided to go with an 8-wheel tank drive using 4-inch Coulson wheels. These are basically just extremely durable little wheels. However, this meant custom bearing blocks, as ours were too large. After talking it over with a group of mentors, we came up with a simple design. We are extremely grateful to Team 1257, Parallel Universe, for actually creating the bearing blocks for us in their shop, as we don't have a CNC machine. Our top speed is 20 feet per second, and thanks to having 1 dual shifting gearbox on each side, we are also able to have a low speed of 10 feet per second. These gearboxes are powered by 4 Falcon 500s, 2 for each side. The wheels are chain run to connect each side to their respective transmission.
Love the deep dive into the drivetrain system, and I love your enthusiasm for drivetrains, right? You know what you like working on, and you are all about it. So James, let's talk about the climber and the intake.
Sure thing, Libby. So the climber intake this year was actually a really interesting part of the robot, and we were actually able to kill two birds with one stone when we were able to actually combine the two mechanisms. So at the start of our game, our intake and climb mechanism actually starts vertically, unlike most teams, and it's actually ripped down by two really large pistons. The intake is dropped to the exact height where the intake system is able to harvest all the power cells. The intake system itself is actually a combo of using vectored intake wheels and just regular wheels to grab the power cells, slide them over towards the center of the intake, and then pop them up into what we call our hopper system. After we actually prototyped this design with some of the old vector wheels we had laying around the shop, we realized that a lot of the power cells were actually getting jammed up against our bumper and not filing into the hopper system. So after a little bit of tweaking of that design and coming up with a couple other failed attempts, we eventually put another set of, I think they were just rubber performance wheels on top of our hopper system that was able to just catch the top of the power cells and pull them up and flick them into the hopper system. On the back side of the intake, we created a small single stage elevator using a couple constant force springs that we had to specially buy and two very powerful and fast winches that would extend the elevator, let it grab onto the balance beam, and then retract and lift the robot up off the ground. The great thing about it was when we were testing the design, we figured out that if we use the Falcon 500 in brake mode, just a simple sprocket reduction and a couple versaplanetary gearboxes, we could set it up so that the robot itself would climb up and hang there for around about climb up, hang, get that done in 6 seconds, and then it would not move forever. We'd have to actually go up, either swap the Falcon 500 out of brake mode or physically grab it, lift the robot off at the end of the match, and then pull it back out.
That's awesome. Yeah, I can appreciate the enthusiasm you have too, James. It seems like you really believe in the final product that you've come up with, and hopefully we'll get to see it soon. So, Gregory, let's transition a little bit here into the hopper and something called the hot dog roller. Can you talk a little bit about those systems?
Yeah, sure. Our hopper system, which we call the hot dog roller, was one of the parts where our new members were mostly involved. The hot dog roller system involves two tracks of rollers or hot dogs. One track is slanted downward to collect power cells that are coming in from the intake off the ground. The second track fed power cells from the first track towards the shooter in the back of the robot. These two tracks were joined in the middle using a plate on both sides of the robot that held bearing blocks, and each end of the tracks were inside the bearing blocks so they were close together. The rollers are made out of pieces of Thunderhex shaft covered in tubing, and along each track over the surgical tubing is an orange band that kept the balls in a straight line. In addition to more rollers, we addressed another jamming issue, which was caused by the friction force between the roof of the hopper and the rollers. And because of this, we decided to cover the roof with Teflon tape, and this decreased the friction force and allowed the power cells to move more smoothly.
Nice. So, Aaron, what about the robot launcher?
Those of us on the team this year did not really have much experience with any type of launching mechanism. But after a lot of research, we narrowed it down to 3 options, which was a monowheel launcher with the hood, a horizontal dual launcher, or a vertical dual launcher, which is like a football shooter. After prototyping with some wood, we decided on the monowheel launcher with the hood because it would allow for backspin, so the power cell wouldn't bounce out of the top of the goal. One of our seniors and 2 of our mentors spent a long time trying to figure out what degree the angle of the hood should be at. They knew it had to be 35 degrees because it allowed for long distance and close-up shots. But after testing, we discovered it launched the ball way too high. One night, right around dinner time, our mentor sat at a table and started writing on a napkin. The senior came over, took a sheet of paper, and started writing as well. The 2 of them sat for a while doing something we have affectionately called napkin math and started to work out the kinks and where they went wrong. They did all of this without a calculator. After some more number crunching, we took some tape, put it on a wall to predict where the launcher would hit. The senior said that nothing was more satisfying than seeing the power cell hit a bullseye on the tape, proving their math was correct. They figured out the dimensions, and after putting it all together and fixing a small mishap that limited the launch height, we finally arrived at the final design with a plexiglass hood to provide the backspin and appropriate angle that also provided an even amount of 2 inches of compression. We covered the inside of the hood with Teflon tape to allow the power cells to move smoothly. And it's on an 80-20 frame to prevent any wiggle room with the power cells. On the frame is a Falcon 500 that can spin up to 6,000 RPM in less than 3 seconds, but we limit it to about 4,500 RPM, and it suits our needs nicely.
This year was actually pretty interesting for our programming department, mainly because last year we didn't set up any autonomous code because we just used an onboard camera for the Sandstorm. So our programming captain had a good chunk of work on his hands. After looking at code from not last season's robot, 2 seasons ago, and working with one of our mentors who is a programmer outside of FIRST, he was able to throw together a really solid auto code where he can actually launch 3 power cells within the first 15 seconds of the game, and it gets us in a good position where we can start our cycle for the next phase of the game. So the programming itself wasn't super complex for him, and it wasn't the big choke point for programming this year. It really was actually the limelight itself. We spent a good 2, 3, almost 4 weeks trying to work on what color hues and values would let the limelight actually target the reflective tape on the high gold the best. We tried testing it in a couple different environments because the lighting at our shop is kind of dim. We went to the gym where it's really bright, kind of like a regular competition. And after a long time, and actually even getting one of our other mentors who is a pretty good amateur photographer outside of FIRST to come in and really help us dial in those values. And once we started getting those values perfect or close to perfect, we saw a great increase in our accuracy, how our program is actually running. And in our autonomous code, we had 0 misses for all of our shots whenever we were running it. And even just through regular gameplay, when we're not just stuck in one position, aiming and shooting even mobile shots, we were still hitting everything great. The turret itself was still rotating. It was locked on and targeting. It was beautiful.
That's awesome. And of course, to be able to vision track and code, it sounds like you guys have a turret. So Erin, I'd like to hear a little bit about that. It seems like it's something you're really proud of.
It was one of the main things I worked on. For me, it was probably the most frustrating thing to do, as I constantly ran into problems where it was unable to rotate or stuck a good 1/4 inch out of frame perimeter. The turret was another thing that the current team had never done before, so I had to look through YouTube videos and all over Chief Delphi for things that teams were posting. After talking with one of my mentors, he went ahead and ordered me a Lazy Susan, which would act as the base and a bearing for the turret. The next thing I did was to create a mounting plate, and we discovered that 1/4 inch plexi fit perfectly inside 25 roller chain, which is what we were using to power the turret. I grabbed a couple of freshmen, traced out some circles in the plexiglass, cut it, and drilled the mounting holes. After some more video looking, mentor talking, we found 2 small sprockets to keep the chain as tight as possible to the plexi, which kept it from popping off and obviously disturbing the rotation. The most heartbreaking part about it was hearing a crack during testing one day. We were running the autonomous program and the turret tried to spin way farther than the program stopped, which is a place where the turret motor would stop spinning. It proceeded to rip the rivets and chain right out of the plexi. After using a reinforced second piece, it proceeded to do the same thing. So we asked a mentor that we affectionately call him the Magic Machine Shop to get a piece of 1/4 inch aluminum, and he came back with a big square that we basically replicated what we did with plexi. It worked almost flawlessly. About a week later, I went to the NJIT open house with my parents, both of whom are team mentors, and we took a tour of their makerspace. They said they were willing to help high school teams out with custom parts, but we figured it would be a good idea for next season. Then we found out another mentor and sibling of one of our seniors just got a job there. Rather than a round aluminum plate, we discussed the idea of a custom sprocket made out of aluminum. We are extremely grateful to NJIT for turning our design into not one, but 2 aluminum sprockets for us using their water jet.
Yeah, that's great. It's cool to use all of your resources, and it's awesome that, you know, on one of your college visits, you know, some inspiration struck and you guys were able to find a solution with a new partner in the college. So that's great. All right. Well, with that being said, 1626, I have one last question to ask you guys, and that is, if we want to learn more about Falcon Robotics online, where can we go to learn more?
You guys can find us on our Instagram, which is SJ Falcon Robotics. And I'm normally on it, so ask away any questions that you guys may have.
All right, we're here with Team 316, the Lunatics from Carneys Point, New Jersey. I've got Frank, Micah, Marissa, and mentor Mike. And you guys are going to tell us a little bit about yourselves.
So my name is Frank. I am a senior on the team. I am one of the co-captains, the leader of the drivetrain sub-team, and I was the human player this year.
Hello, my name is Micah. I'm a junior, and I am the CAD and manufacturing lead as well as the safety captain.
I'm Marissa. I'm a senior. I'm the intake lead and operator.
All right. Yeah. Great to meet you guys. Super big fan of 316. Love the imagery. Always look forward to what kind of robots you guys produce each year. So I'm excited to talk with you tonight. And now that we've learned a little bit about our student ambassadors here, Frank, maybe you can tell us a little bit about the 316 team history.
So our team began in 1999. We started with 7 students and 4 mentors through a partnership with DuPont and Salem Community College. We were originally named the Jersey Fried Robots, with our logo being power tools coming out of a chicken bucket and Einstein on the bucket instead of Colonel Sanders. But our head mentor at the time was the only one that liked that. So it was changed to Lunatics, which is an acronym for Learning Under Nurturing Adults, Teaching Engineering Concepts and Skills. And then in 2008, we started a nonprofit organization called South Jersey Robotics. Through our 12 years with that, we have founded multiple FLL Junior, FLL, and FTC teams, as well as FRC Team 5420.
I have to tell you, I've been in First Mid-Atlantic for my entire life, and I have just today, I am today years old when I learned what Lunatics stood for. So thank you for that. What about your guys' outreach programs? I know you do a lot in your community, so how do you build that?
Well, during the summer, we run a week-long STEM camp that teaches kids from the community about robotics and STEM through New Jersey Education Association curriculums. We also have an annual Robot Run 5K, and that is something that we do to get our name into the community. It is a race that we put on, and we display our robots from all levels of FIRST, and it's one of our biggest fundraisers. Through SJR, our team has also helped local FLL teams by hosting and running the largest FLL qualifier in Southern New Jersey for the last several years. This brings us to 2020. This year's FLO qualifier, as well as an FLO Junior Expo, fell on January 4th, which just happened to be the same day as our FRC kickoff. So as a result of this, many of our students did not even get to watch the live reveal of the 2020 season. Because of this, we got to a little bit of a late start, but nonetheless, once the qualifier and expo were done, we got straight to work.
Yeah, I commend you guys for having the discipline to allocate some of your team to the expo on such a momentous day for FRC teams in the kickoff. That must have been a challenge for sure.
Micah, it says here this is your team's second year implementing CAD as a sub-team, so I'd love to hear about that evolution for you guys.
So before the 2019 season, which was actually my first year in FRC, our team had never used any type of computer-aided design software. So my freshman year, I was actually made the CAD captain. And because no one on our team had any real knowledge on CAD, me and my fellow CADawan spent a majority of last year's build season figuring out how to use the CAD software. Because of this, we didn't finish the CAD of the robot until after our first competition, because we had spent a majority of build season learning the software. And so there was minimal practical use last year other than an occasional measurement that a sub-team needed for one of their mechanisms. This year was different, however, because this year our CAD actually had a deadline. We had to finish the complete CAD of the robot by the end of week 2 of build season. This was a huge leap from our previous year. As well, this past year's off-season, our team purchased an Omnio CNC router. We spent quite a few months figuring out how to use this new machine so that we could be capable of using it effectively for manufacturing parts during build season. So not only was Infinite Recharge our first time finishing the CAD before the robot instead of vice versa, it was also our first time CNCing a majority of our own pieces. This had a lot of challenges because it meant that every mechanical sub-team had to come through CAD before they were able to start assembling their mechanisms. So there was a lot of coordination and communication that had to be withheld between the sub-teams and the CAD team.
Yeah, that's impressive. Anytime you take on a new concept, in this case CAD design, and a new method of manufacturing, there's a lot of learning that needs to be done to do it efficiently. So I commend you guys for being able to apply both of those new concepts into your build season this year. Marissa, we've learned a little bit about how the team goes about moving through build season. Let's learn a little bit more about the robot.
Yeah, so for the past 3 years, we've been using a 6-wheel West Coast dry chassis as opposed to the kit drivetrain. And this year we decided on a 32 by 27-inch frame with the chain inside of our box tubing. This was the first year that we CNC'd and machined our drive rails and custom made our own gearbox plates that held our 4 Falcon 500 motors. We had problems at the beginning with the Falcons, but after fixing them, they performed very well. Next, we had the intake, which includes 4 rollers. The first roller was made from a hex shaft with 11 2-inch straight flex wheels on it, and the other 3 were made from Versa rollers surrounded by abrasion-resistant rubber tubing from McMaster. The roller with the flex wheels and 2 of the rollers with the rubber tubing were attached to polycarb panels, which flipped out of our robot to help pick up power cells. We used air cylinders to deploy and retract the intake. And the third rubber tubing roller was stationary, held up by 2x1 box tubing. We decided on 4 rollers so we could have the same amount of compression on the ball all the way through, and this would allow us to bring it up high enough to be stored in the feeder of our robot, and all the rollers were controlled by one 775 Pro motor. Next, we had our feeder, which had 2 parts. Our version 1 feeder had what we called the Flying V that brings the balls into the center of our robot so we can hold 5 and feed them efficiently. The second part was our tower, which the Flying V feeds into. That carries the balls into the shooter. We did a lot of research from previous games where you had to hold these kinds of balls, and we found this to work the best. However, the Flying V did have a tendency to get clogged up. So after Connecticut, we decided to quickly make another feeder with surgical tubing that spins to be able to comfortably hold 5 balls and feed faster. And we started by prototyping a standalone climber with rollers that would allow us to move along the bar to aid in balance. However, that was set aside due to space restrictions as we assembled the robot and had to create a new design nearly midway through build season. And we ended up creating a collapsible climber that allowed us to go through the trench and a hook that flipped out into place, allowing us to nearly reach the full height of the bar when tilted. The climber was made of 2-inch and 1-inch aluminum box tubing and bearings running through it, inspired by 254's 2016 climber. And this all was powered by 2 air cylinders and a 775 Pro motor.
I always find with the short robots, it's such a different space challenge to be able to reach up and do that climb. So sounds like you guys nailed it. I appreciate the overview, but Frank, let's look at the highlights. What are the parts of the robot that you guys are most proud of?
One of the most proud parts that we are proud of is the shooter and the turret. We should preface this by saying that in 2016, which was Stronghold, we didn't make any shots in the castle until off season. So we knew we had to really improve on that. And this year we put a lot of time, effort, and research into this to be able to make the best shooter the team has probably had. So to accomplish this, we used 2 4-inch neoprene Fairlane wheels with 2 steel flywheels on either side, powered by 2 Neos geared up to 1 to 1.5. We also had an adjustable hood powered by pneumatics to be able to alter our shot from a near to a far shot. Our tracking was consistent by the end of Northern Connecticut. We were able to track from the front of the color wheel to the baseline, and we were fairly accurate from most places, the baseline being our most accurate. Our tower, which fed from the Flying V into the shooter, was able to effectively feed them to the shooter regardless of what angle we were shooting at. That leads us to our turret. This was the first year that we had successfully used a turret, so we did a lot of research and put a lot of time into making it work. We used the turret so that way we could use our limelight to track the goal easier. And the turret was very successful in helping us shoot while being defended and being pushed around.
Lots of really impressive aspects to that robot for sure. Marissa, can you tell us a little bit about the software that ran this robot?
Yeah, programming is very important to the Lunatics. So during build season, we work with the mechanical teams, electrical team, CAD, and drive team to first understand what they are building and then work with the teams to help them understand what sensors and motors or controllers are needed to make their vision a reality. So for example, our turret can only rotate 270 degrees. So they worked with the electrical and mechanical team to place 2 magnet limit switches that are tied into a Talon SRX controller to limit how much the turret can turn. This year, our electrical team challenged the programming team to tackle vision targeting in the off-season, and the programming team did it, which paid off for adding tracking to the turret. Also, the programming team challenged the mechanical team to have a really solid drivetrain this year, and it is paying off in what the robot can do in Auton. We went into Connecticut with a very consistent 3-ball auto, and we were working on a 6-ball auto for Springside Chestnut Hill.
I love the idea of all of these challenges across sub teams. It's like, yeah, well, can you do this? I love the way that you phrase that, right? Where whether it's in the off season or the real season, you're sort of supporting each other and scaffolding each other, but also pushing each other to do more and make an even more awesome machine. Now you guys keep referencing that Northern Connecticut event that you've been to, which I know we're going to hear about in a second. But before we talk about competition, Micah, I'd love to hear about scouting and strategy.
We wanted to be able to have match-by-match scouting data. So we actually use a customizable scouting app provided by Team 2052 Nightcrawler Robotics. This information that we gather is fed into our custom Excel program. At our competitions, this was done in real time. So as a result of this, instead of manually calculating all of the data for alliance selections, we would be compiling it throughout the competition. Our lead strategist brought the scouting data down to the drive team before every match to discuss how to approach each match. With the information we gather, we are able to predict the scores and probability of each alliance winning for any given match. So this gave us the benefit of being able to come up with a strategy with our teammates in the qualification matches, depending on what their robot was capable of doing according to our data.
Yeah, it's awesome that you guys recognized instead of spending too much time trying to produce a scouting app of your own, you guys went out and found one that was already developed and fit your needs, and you were able to capitalize upon that. So props to you guys for that. Marissa, 316 is one of the few teams that we've covered on FMA Plus that has had the opportunity to not only compete, but to compete outside of the region. So I'm really interested to hear about your reflections on competition in Northern Connecticut.
For the past 3 years, we've been attending an out-of-district event for week 1 to put our robot through the paces while having a less stressful experience. So our strategy for this game specifically was to go through the trench, pick up 4 or 5 power cells, depending how many were there, and go back and shoot from the initiation line or the part of the trench closest to the port, so we were still guarded. We focused on scoring as much as possible since we do not have an attachment to control the color wheel. And for endgame, we wanted to solely climb or level climb with another team every match. We also used this time in Northern Connecticut to work on adding more autons. And for our drive team, initially the hardest part was visibility. With having the rendezvous point in the middle of the field and on a slant, it created a tough environment to see across. And before this competition, we talked about having another camera other than our limelight, but we decided to wait to see how this first competition went. Also, during the matches, we would leave our limelight on, but unfortunately, the judges asked us and other teams to only track when we were going to shoot. So we had to quickly reprogram our limelight to only track when we were in sight of the port. During qualification matches, we went 9 wins to 3 losses, and this allowed us to move up in ranks to be 4th at the end of qualification matches. We chose Team 78 Airstrike and Team 7760 Palmtech. We started experiencing electrical shortages caused by the limelight that would dribble the ball, so we were missing half of our shots. Also, every team on our alliance had at least one part of the robot break, and because of this, unfortunately, we were eliminated in quarterfinals to the alliance who ended up winning the whole competition. We were the only team to bring a bandsaw, so lots of people were in and out of our pit, and we were able to meet a lot of other teams. And even though this was not in our district, all weekend we had judges coming into our pit, and we were very excited about that. And that resulted in us being awarded the Quality Award.
That's awesome. Congrats. Now, As we ask a lot of the teams with competition experience already in 2020, as we look towards 2021, what's next? What upgrades would you make, or what changes would you have done if you could see if you knew what you knew now?
Well, now that we have all this extra time we are given since the game will be repeated in 2021, we plan on making more upgrades to our feeder. With the upgrades to our feeder, we will probably also end up changing the intake as well so that we can downsize to 3 rollers instead of 4. Even though we were very happy with how we performed in Northern Connecticut, we do plan on making changes to our climber and our shooter as well. Our team has been planning on testing out Swerve Drive this offseason so that we can soon implement it into our drivetrain arsenal. And sadly, since we are a relatively small team of 15 people, this year we have 5 graduating seniors, but we hope to have some new students joining us this fall despite the current world situation.
Definitely a trial or tribulation of smaller teams, watching your most qualified students graduate out. It's bittersweet for sure, but I'm sure 316 has the ability to overcome that and move on further into the future, like you said. Right. So, Frank, is there anything else about Team 316 that you'd like to let us know about?
Yes. On behalf of Team 316, we would like to thank our generous sponsors, starting with Salem Community College. They were there when we started. They have let us work in their shop rent-free for 20 years. So we would like to thank them first and foremost, as well as the Boeing Company, DoD STEM, Corteva AgriScience, Intuitive Foundation, and Lockheed Martin.
Well, of course. Thank you, sponsors. I love the stories of long-standing relationships like that with really foundational organizations. If I want to learn more about Team 316, the Lunatics, where can I find you online?
You can find us on Instagram, Facebook, our website. We also have Twitter, and any of those we will be able to contact you through.
Awesome. Well, thank you guys so much. It was great having you on tonight. All right, we're here with Team 341, Miss Daisy, another one of our Hall of Fame teams in the Mid-Atlantic region. I've got Milan, I've got Jackson, Chris, Katie, and Catherine, as well as mentor Kirsten. So why don't you guys introduce yourselves and tell us a little bit more about Miss Daisy?
Hi, I'm Jackson. I'm a sophomore, and I primarily do design and build.
Hi, I'm Catherine, and I'm a junior on media and public relations.
Hi, I'm Milan. This is my second year first, and I am part of the build, design, and drive teams.
Hi, I'm Chris, a senior on the team and a programming lead.
Hi, I'm Katie, a senior co-captain on the team, and I primarily work on game strategy and builds.
Awesome. So, big fan of Miss Daisy. They're one of the quintessential teams in our region. I'd love to learn a little bit more about the team itself, and maybe you guys can talk a little bit about how you kick off this season's game strategizing.
Yeah, of course. So we're Team 341, Miss Daisy, from Wissahickon High School in Ambler, Pennsylvania. We're a team of about 50 students and a Hall of Fame team as of 2010, when we were honored to win the Championship Chairman's Award. We start off every season with a full weekend of strategizing at kickoff. We were so excited to start the season. After we watch the kickoff broadcast and read the game manual, we start to discuss what we want our robot to do. A big part of our strategic process was our newly revised weighted objective table. This year, we broke down every game task into scoring and non-scoring tasks. For scoring tasks, we came up with a formula that factored in total points possible, potential points per objective, ease of design, and ranking point contribution. For non-scoring tasks, we discussed the percentage of time this would be needed, the time saved by using it, advantages, and points that could be earned through it. In order to get a better idea of what the game might look like, we play a mock game with students as robots. We play this in 15-second increments, allowing us to recognize trends and discuss scores. We play with handicaps too, such as closing our eyes in auto and doing the YMCA dance to emulate the time and effort put into climbing. Afterwards, our team votes an objective into 3 categories: need, want, and don't want, and then we take it to the strategy sub-team to flesh it out into more concrete strategy. We had a long discussion about whether or not we wanted to go under the trench, and ultimately decided that it would be in our best interest to do so, since then we could go anywhere on the field.
How does your strategy play into the design and manufacturing of the robot?
Well, the decision that we made at the start of the season was that if anything touched a ball, it must be made in-house and not by our sponsors. This was to ensure that we don't overload our sponsors and to ensure that we can always fix it. Our sponsors, Penn State Great Valley, cuts plate materials such as metal and polycarbonate for things like hooks, and Computer Components Corporation cuts sheet metal and bends it, which we use primarily in our drive bays. Another thing that we utilized a lot this year was a laser cutter that cuts out MDF plates, which allowed us to design and test on the same day. This was used in many of our ball path prototypes, and we even used it to lay out electronics before our drive base came. We were also able to use our school's new CNC routers to cut the final plates for the shooter and conveyor in-house. And moving on to our robot's final design, our drive base this year had six 6-inch pneumatic wheels. It went about 12.5 feet per second with a Cuts gearbox and Vex, and we had 6 Neos in total, giving us a lot of pushing power. Our first power cell subsystem is our over-the-bumper intake. We wanted this intake to always have full control over the balls, to take in as many balls as we wanted, and to package nicely. We tried out a lot of geometries and looked at using a 4-bar. However, this ran into our climbing mechanism, so we went with a pivoting intake. Our final design is powered by a Neo 550. It is made of 1/4-inch polycarbonate, and it is actuated by 2 pistons. Our intake is 3 balls wide, so that it is able to pick up balls no matter where they are on the field. Our intake had only compliant wheels, but during Hapro, we noticed that the balls could get stuck between the brackets the intake was mounted on. Our quick fix to this was to add an angled plate and mechanism wheels to funnel the balls towards the center. The next power cell subsystem is what we call the sorter. The goal of this subsystem is to funnel the balls from a 3-ball wide intake to a 1-ball wide shooter. It uses compliant wheels on one side and a polycarbonate plate acting as a wall on the other. The entire mechanism is also slanted, which pushes the balls towards the shooter. If 2 balls attempt to go into the shooter at the same time, the ball that contacts the wheels will be favored. Instead of getting stuck together, the ball will go upwards and recycle itself. This mechanism is also easily removable because our Robo Rio is right underneath it. And if we ever want to access it, all we have to do is take out 2 bolts held on by 3D printed blocks and 2 pins in the back. When we prototyped, we tried several iterations of this, including top and bottom rollers, a prototype that had 3 sets of rollers, 1 on each side and 1 on the bottom. But in both, the balls would still stick to each other. And we also tried putting mechanism wheels on the top, but the balls would still jam because they could not go anywhere but forward. The conveyor follows the sorter and leads directly to the shooter. This mechanism transports the power cells using a polyurethane belt that we welded together. We also use 3D printed pulleys, which allow us to change the compression of the conveyor by swapping the pulleys. After Hapro, we changed the conveyor up a bit, replacing one of the sets of pulleys with a wheel to reduce compression, increase control by removing a jam point.
So our shooter prototyping process started with 2 designs, the 2-wheel shooter and the hooded shooter. When discussing which mechanism to go with, we weighed the advantages and disadvantages of each. The 2-wheel shooter prototype made it easy to hit the middle goal with about 30% accuracy. It didn't require great speed control and appeared to handle ball bearings well. On the other hand, the balls bounced back when they didn't hit the inner goal because the balls flew with no spin. This didn't guarantee 2 points every time, which we defined as a need at the beginning of the season. This mechanism also needs a lower arc to hit the inner goal, which would make our shots much easier to block. The hooded shooter prototype came with its own pros and cons. We've made a hooded shooter before, and we knew it would be consistent once we got it right. The prototype was extremely consistent on a single ball basis. It also added backspin, which ensured that our shots got 2 points every time, even if we missed the inner goal. Once we improved our prototype by adding a motor and flywheels, it was much more consistent. Ultimately, we decided to go with the hooded shooter. To make quick changes during the prototyping process, we used our laser cutter to make new MDF side plates and simply switch them out. The final mechanism shoots up to 5 power cells in 3 seconds from 8 to 30 feet away, using 2 4-inch urethane wheels powered by 2 Neos. We also have 5-inch flywheels, a 2-inch compression wheel, and a limelight mounted on the front.
Awesome. Yeah, that's a super thorough dive into the primary functions of your robot. But I'd love to learn a little bit more about how you guys approach the end game.
Sure. For our climber, we decided to use a 4-stage cascading elevator powered by a Neo 550 with a detachable hook. We wanted an elevator because it could easily serve the purpose of delivering a hook to the bar without being too large. It was also designed to reach the generator switch at any of the bar's heights, and after being successfully deployed, we would winch ourselves up with 2 Neos. A major factor that affected the design of our elevator was that we wanted to go under the trench, so due to our elevator's small size, we made replaceable 3D printed bearing blocks to maintain a compact design, which also meant that they were easy to replicate if they needed to be swapped out. We also deemed it necessary to have a detachable hook because our elevator did not have the structural capacity to carry the load of the entire robot. This had many iterations during prototyping phase because we were hoping to make a hook which could passively grip the bar, though we later found out that gripping the bottom of the bar was irrelevant. Here's a quick visual of how the mechanism works. You can see that the stages all rise at the same time. That's why it's called a cascading elevator. We are really excited for our robot to climb at competition. However, after Hatboro, we realized that our hangar could use some improvements.
That looks really smooth, and I can't wait to see what the improvements are too. So Chris, could you tell us a little bit about your software?
Of course, our programming team this year went above and beyond in every aspect. With the programming team being the largest it has ever been and having such a large class of rookie programmers, we had to develop a new curriculum during the fall. During the season, we paired up rookie and veteran programmers to work on different aspects of our robot, such as vision, LEDs, subsystem control loops, code simulation, and autonomous. For vision, this year the team decided to use a line light. Data from the line light is used to calculate the distance and angle offset from the goal. The angle offset is used to align our shooter mechanism to the goal, while the distance is used to calculate a desired RPM for the distance. To allow for our shooter to quickly fire 5 balls, code was written to keep the shooter at a base RPM so that we could minimize the time it took to spin up to the required RPM. For autonomous, our programmers created pre-written paths that work with vision and other various aspects of the robot. During our competition at Happer Horsham, we didn't have a chance to debug our autonomous as we primarily focused on robot repair and improvements. However, after competing, we were given an opportunity to go to 103's practice field and debug our auto paths. This gave a lot of our rookie programmers their first chance to test out their auto paths, culminating in 3 autons capable of 5 or 6 balls each. Of the various subsystems, the control wheel mechanism was one of the most interesting to program. Our mechanism consists of a hard stop and a compliance wheel attached to a Neo 550. The hard stop and wheel are attached to pistons that raise them from horizontal to vertical. One feature is the robot's ability to auto-align to the control wheel. The robot drives up to the control wheel at a constant velocity. When either the hard stop or the wheel comes in contact with the control wheel, a limit switch is pressed and that side of the wheels on the drivetrain will stop. This makes it so that the robot will end up flush against the control wheel. On the wheel part of the mechanism, there is a color sensor that is used for both position and rotation control. For rotation control, the wheel rotates the control wheel and using the color sensor detects when the color on the control wheel changes. The program counts the amount of times the color changes and determines the amount of revolutions completed. Position control uses an algorithm that uses the color given by the field and determines the color perpendicular to that color.
Wow, that's awesome. Unfortunately, for most teams, but fortunately for you guys, you're one of the few teams who had gotten a chance to compete this year. Maybe you guys could talk a little bit about that experience.
Yeah, our competition experience was definitely a roller coaster of frustration, surprise, and excitement. Our first few matches went decently, though we had some Alton issues and minor ball jams. Additionally, balls kept getting caught in our conveyor because we had not yet completed testing the system. As quals went on, our robot was especially lacking in reliable shooting, in taking balls, and eventually we discovered that our hanger was difficult to service since we did not have the time to fix it in between matches after it breaking. By the end of Saturday, we realized that we need to make some pretty big changes. On Sunday, though, as qualification matches came to a close, we decided to focus on playing defense. We saw it as, okay, we're in 36th, so it can probably only go up from here. And by the end of the match, our whole team was amazed at how powerful our drivetrain was and the strategic advantage that it could give our lines. That match helped put us on the radar for a line selection, and we are excited to have been selected by teams 365 Mo and 5895 Petty. Our first limbs match with them went extremely well, and we were getting into the flow of playing defense. Meanwhile, the rest of our team in the stands were surging with spirit. We continued to play defense throughout the rest of the limbs, and I think it was just a surprise to everyone how our robot excelled at something that we did not initially prioritize. At the end of the limbs, it was able to get us our first win in roughly 4 years, so it was definitely a really cool weekend for the whole team. After a successful weekend, we began working on what our robot was actually supposed to do, which was to hold and shoot 5 balls quickly and effectively, and climb an endgame in under 13 seconds. Once again, we split off into groups and tackled our climber by paralleling development of a telescoping arm while improving our current mechanism. We aimed to end up with 2 improved designs, one of which would eventually be chosen as our main climbing mechanism. We designed a telescoping arm similar to our 2018 robots climber and made reinforcements to our current elevator, such as the addition of constant force springs, strengthening of the bearing blocks, and developing a solution for the Spectra cable on the elevator, which caused maintenance problems. Meanwhile, our ball path group began working on intake redesigns, which aimed to prevent the power cells from getting stuck and adjusting ball compression in the conveyor to address our jamming problem. We were hoping to see all of these improvements pay off at our next competition. Although we recognize all the faults in our robot designs, we also realized how valuable our new scouting database proved itself to be throughout Hatboro.
So before last year, our database was a website, and in this format, we struggled to effectively utilize the stats that we collected. We wanted to find a way to easily organize and visually interpret our data. During competitions, we have a rotation of 6 scouts collecting data on every robot for every match. Because of this vast amount of data, we needed to come up with an effective way to use it. We settled on a Google Sheets database and came up with different tabs to organize data in various ways. The Quick Search tab allows us to search for a specific team and see match data, averages, a picture, and qualitative observations. The Event Graphs tab visually organizes the data in an easy-to-understand manner, under categories such as auto and teleop averages and maxes, climb rate, and shooter accuracy. We also have an Alliance Compare feature that can be used before matches to input 6 teams and see what a match might look like. We also have many other tabs, including overall robot ranking based on weighted categories, team averages, and more. During quals, these are extremely useful for pre-match discussions. We also take videos of each match and have an analyst discuss with the drive team afterwards to help give real-time feedback on what can be improved from match to match. During elims, this is also a big asset for our Alliance partners because of the comprehensive data we have on every robot.
I really appreciate the look into your system and definitely want to see it in action in a competition soon. Now, obviously, you guys also have a large media presence on Team 341. Could you tell us a little bit about that?
This year, we really embraced the Star Wars theme as we developed some branding for our PR materials. Our media team worked throughout build season to design buttons featuring Baby Yoda and our own version, which we have come to call Baby Daisy. Our avatar for the scoreboard even features Daisy in a Jedi hood, and our robot art includes our own Star Wars emblem. Earlier on in the season, one of our mentors crocheted Baby Yoda and Baby Daisy, which was always really fun to just have in the shop and at competitions. It's little things like that that keep us laughing and having fun, and that was really important for this year especially. What has kept us strong through this unprecedented time has been our strong bonds with one another. Each year, we always work really hard to integrate rookies into the team culture. This year, that manifested itself in bowling nights, game nights, and the revival of a tradition we call Big Daisy, Little Daisy. With that, we put rookies and veterans in smaller groups, and the close bonds that they form with one another eventually trickle into the rest of the team. This natural team camaraderie also keeps us spirited through the ebb and flow of competition. Regardless of what was happening on the field at Hapro, you could always hear our cheers and see our Daisy headbands in the stands.
That's awesome. Yeah, I appreciate you guys put an effort into trying to keep your team spirit high and keep the camaraderie high as well. So one last question for you guys. Where can people find out more information about your team if they want to learn more?
You can visit any of the social media on the screen to learn more about our team. We would like to thank our sponsors who have allowed us to build a robot and team we are proud of each and every year. We'd also like to thank our mentors, team parents, and Wissahickon School District administration and maintenance staff for their unwavering support through what has been an unprecedented year for our team. Thank you for having us.
We've certainly loved having you join us tonight on FMA Plus, Team 341, Miss Daisy.
Awesome. Yeah, what a great collection of teams we had tonight. Everybody, don't leave too soon. We do have a quick Q&A session coming up just after this with Team 341, Miss Daisy.
And we're here for our live Q&A with Team 341, Miss Daisy.
Awesome. Yeah, with that, tonight we have Katie, Chris, Catherine, Jackson, Milan, and their mentor, Kirsten, from Team 341, who we heard from a little bit earlier in the broadcast. So we're going to jump right into some questions. Remember to keep posting your questions in the chat, as we'll be picking out more during this Q&A session. So Libby, why don't you go ahead and ask the first one?
Absolutely. So there's some exciting news in the FMA region. Can you guys tell us a little bit about the award that 341 won just yesterday?
Yeah, so a couple weeks ago, we took on the challenge of OnShape's Robots to the Rescue, which, if you aren't familiar, is essentially designing a robot in OnShape to fit any problem that you see in the world. So a couple weeks ago, we teamed up with 5407 Wolfpack, and attack the problem of COVID-19 in zoos, primarily because of the news of lions and tigers contracting it from their zookeepers. So we developed 2 separate robots to deal with that problem. If Jackson wants to talk a little bit about that.
Yeah, so for the design of our robot, we had 2 main tasks, which included intaking the dirty bedding and dispersing the new bedding. So for intaking the new dirty bedding, we use an intake at the front of our robot that's attached to a chain elevator to pick it up with a brush. And in the back, we have a dispersing mechanism, which uses 3D printed augers to disperse the bedding. And then the Wolfpack robot was primarily used to entertain the robots, and it could flip upside down with pretty big wheels.
Very cool. That's awesome. Yeah, I can say, Libby will probably know this already, but given the occupation of my wife running a horse farm, if you guys are interested in actually fabricating this prototype and giving it a test drive, I would totally love to see that clean the stalls out instead of me. So appreciate the effort there, and a definite real world problem to be solved for sure. All right, cool. So next question up. This is one of the more hard-hitting questions, so brace yourselves, guys. Daisy won the Championship Chairman's Award and was admitted to the Hall of Fame in FRC back in 2010. How has that legacy been passed on to new students in the decades since? And do the students feel connected to the award win?
Yeah, so I think students on the team right now, I think we try to spread a lot of appreciation for that legacy, and we try to live up to it. The team really tries to make sure everything we do embodies the spirit of the team and the spirit of the award. We teach a lot of team history. Every year we have at least one team history talk, sometimes even more. Either this year or last year, our team's founder came in to give a talk. And I think that helps us stay connected to how we really stay connected to our values as a team. And we really try to stay connected to the community as well, and try to make sure that we're still reaching out and embodying the Chairman's Award, so we can spread STEM in the community.
Right, and recently, in recent years, we've definitely taken to that a lot more. We have improved our Sparky's Robot World exhibit, which is an exhibit of 3 robots that kids can drive. And we've brought it to a bunch of different places, including like Robot Stock and street festivals in our area. But improving that project and making sure that younger kids can become familiar with our team when they're in elementary school allows for students in our district to eventually join the team with a pretty good understanding of what we do. And it just makes us really proud to carry the Chairman's Award and its prestige into everything we do. And we always kind of just want to remember that it's something that we should be proud of and also never take for granted.
I really like hearing that. I know the Hall of Fame, of course, being the Championship Chairman's Award and the highest honor given in first. I grew up raised by chairman's judges, and to hear a team that earns their spot in the Hall of Fame and then keeps that legacy going is so exciting. Like, that is what it's all about, and proves that you earn the right to wear that beautiful badge on, I don't know where you guys put it on your sleeves, right? Anyway, you know what I mean. I think the Hall of Fame is such a special thing in the FRC community, and it's so awesome that we have a couple of Hall of Fame teams in the Mid-Atlantic region. So our next question comes specifically from chat. Miss Daisy, Team 341, do you love scouting?
Yes, we love scouting here on Team 341. This actually came up a couple years ago because when I first joined the team, at least I hated scouting, and it was the whole culture around scouting was that it was something to be dreaded, something that wasn't really fun. But last year we kind of came up with this idea to spread propaganda about scouting and to make it really sound fun and everyone trying to get involved in it. So we came up with this chant, for better or worse, we came up with this chant. And it's about loving scouting. And it's just really fun when we're all scouting together. It's just trying to make the whole atmosphere surrounding scouting a lot more fun and trying to make the whole experience more than just sitting and watching robots. So that's something that's become really important to our team recently too.
Awesome. Obviously, I'm going to ask, what is the chant?
It goes, I love scouting, yes I do. I love scouting, how about you? And then it just keeps going back and forth. You can call out a specific person, or it can be one person for the whole team against the whole team, and we just do it until we're exhausted. So it's so much fun. So I really hope that it kind of made scouting a lot less dreadful and kind of more something that you actually enjoy doing, because that's definitely how it became for me.
Nice. Yeah, I know. If for those of you that watched the coaches panel from last week, one of the points that 1089 Mercury's coach Chris Gregory brought up was the importance of making scouting something that people are interested and competing to be a part of, versus it being a chore or an afterthought or something that somebody doesn't want to do. So I appreciate the 341 aspect of making scouting fun and appealing to the masses. So awesome, guys. All right, here's a bit of an interesting question specifically pertaining to your experience at Hatboro Horsham in 2020. Daisy was the last team picked during the Alliance selection at Hatboro. How nervous did you guys get as team numbers were called out?
It was certainly really nerve-wracking. I think our performance throughout qualifications certainly ebbed and flowed, but for the most part, we were in large disappointed with a lot of our robots' performance. And so by the time we got to Alliance picking, we were in a pretty rough spot, and we ended up being the last pick. But I think that amounted to a lot of excitement when we were picked by Mo and Petty. And that's definitely one of the most memorable I've had on the team is that moment. And everybody's just excitement. Everybody was like crying and hugging. It was really, it was nerve-wracking, but it was certainly a really fun experience.
Yeah, for sure. Getting picked at all is such an exhilarating experience when you're playing and you're grinding to be able to play on that last day's afternoon, whether it's a Sunday at a district or a Saturday at district championship. There's such a relief in oh, we got picked. And I know the further you go down that draft, the more exciting it can be. Well, you guys got to play this year, like we said, at that Hatboro district, but also, of course, as we all know, first announced that we'll be replaying the Infinite Recharge game next year as a part of the 2021 First Game Changers, sponsored by Star Wars Force for Change season. But they also said they're going to get some twists. It's not going to be necessarily exactly the same. There might be some adjustments to the game. So one of the questions we would love to ask from a team who's already competed is, what kind of changes would you like to see after that 2021 kickoff for Infinite Recharge?
Something, I'm not going to be here next year, but I really would love to see the control panel be used more. If we can lower the requirements for actually using their control panel, I think that'd be super cool, because then we would see it a lot more often. We'd see which teams kind of prioritize that, because would you take the control panel or would you continue shooting balls? What would you pick? Those kind of decisions that are made. I think it would be really cool to just see that happen more, because I know most teams built control panel mechanisms, but very few were used. So I'd love to see that, especially for our software group this year. They did such an awesome job, and just seeing that, I think that would be awesome.
Yeah, I personally don't have any specifics that I would like to change. I'm sure that I will eventually come up with some, but I do really hope that the climbing task ends up staying at least a little bit similar to what it is now, because I think it's really unique how it moves, and I think the mechanisms that I've seen so far are really interesting, and I'd love to kind of see how teams continue to play out with that.
Absolutely.
Oh, sorry.
Go ahead, sorry.
I'd love to see them throw another strategic challenge in there. I don't know what that would be, but kind of having force teams to rethink their game plan and reconsider what they think is important. I think that would be really cool, and kind of how kind of how to use your robot to its full potential.
And then building off of that, I would like to see a lot of the points getting changed so that they're completely new strategies, and maybe end game or climbing would happen at a different time, and shooting could be worth different things. And I would just like to see the entire game get mixed up. So maybe climbing is more earlier and shooting is later, and control panels get utilized more.
Yeah, I also think it would be interesting to maybe change some of the mechanics of the power cell goal to possibly instigate new scoring mechanisms, just to like kind of switch it up a little bit.
Absolutely. Yeah. I think that was one of the more exciting aspects of our coaches panel last week, was hearing some of the proposed changes, starting on the bar instead of climbing the bar at the end, and, crazy new game pieces and stuff like that. It sounds like everybody is in agreement on that. And it seems like a lot of people are in agreement on the fact that the control panel needs to be more accessible and more integrated into the main gameplay. So I agree with that as well. Okay, cool. So here's an exciting question for 341. How did you guys build such a strong imagery and branding culture? 341 is known for their branding, for their imagery, for their clean look, but also not very much of a plain look, right? Like, you guys are loud, you're bright, you're in your face, but you're tasteful. And I think a lot of people stand to benefit from learning a little bit about how you guys achieve that as a team.
Well, thank you for the compliments on the branding, but I think something that certainly shouldn't be overlooked on first teams is branding and your imagery. I think whether you are really involved in your community or not, it certainly helps to have your name out there and for people to be familiar with you. So we have kept a pretty consistent brand throughout our years, and we've obviously updated it to become a little more modern. But our media team works really hard every year, primarily in the Adobe suite, to continue to build that brand in whatever PR materials that we have. So every year we're designing posters for our pit and our design binder business plan. We got new practice day shirts this year. And those aspects that's what people remember at competitions. So having a core group of students that learns that expertise to essentially apply their knowledge and their knowledge of our brand to create really interesting shirts or whatever the case, that's really valuable. And I think a lot of first teams can benefit from not having media be something that's in the background, but incorporating it into its own sub team or something like that, or advertising it as an opportunity for students who are artistically inclined or something like that. I just think it's really important for kids to be dedicated to that cause.
As someone who works in marketing and branding, I could not agree more with you in that it is absolutely not a background thing, right? Like, and I actually would love to, like, not a Q&A topic, but at some point dive in with you guys on how you utilize the Adobe suite across the team, because that's just like genuinely interesting to me. But, maybe not all of our chatters, so we'll leave that for another time. Our question here in chat, though, is, of course, we're all familiar with the Miss Daisy brand, including the iconic headbands. And the last question I'm assigned to ask is, how can Jeff get a Daisy headband?
We are alliance partner, but then you have to give it back, so.
Oof,
Wait,
okay.
You have to give it back now? I still have my old ones.
They are strictly for rent. You cannot keep them. They take a lot of work to make. We hand make all of them. So for the most part, if people ask for them at competitions, we unfortunately have to decline.
I feel honored.
We are very happy that people want them bad enough to ask. I think that's pretty brave. So I'm sorry, everybody, they are not for sale.
That's amazing. I will hold on to mine from before the rental days even more tightly now, so that Jeff doesn't steal it next time I see him in competition.
For sure. All right. Well, cool. I guess that's going to do it for our chat questions. So thank you to Team 341, Miss Daisy, for your time tonight, guys. I really appreciate you, taking a few minutes with us.
It's been great. Of course, a huge thank you to our entire FMA Plus crew for helping make this happen. We couldn't do this without the whole group who were screening, interviewing, and editing down these team features, as well as moderating chat, coordinating social media, and keeping you guys informed.
Absolutely. So we'll see everybody next Saturday night around 6 p.m. for another awesome episode of FMA Plus. Have a great night, everybody.